So today we're going to start taking a look at this cumulative review. So the first question, the equation x squared minus 3x plus k squared equals 4 has two distinct roots. Find the values of k. So let me get to, whoops, I guess I didn't send this over. I thought I did. So let's go back here. I'll send it so I can write on it. All right, so that it has two distinct roots. Well, we know that this means our discriminant has to be greater than 0. So let's set this equal to 0. So we have x squared minus 3x plus k squared minus 4 equals 0. And now we know our discriminant to have two real roots. It has to be greater than 0. So b squared minus 4ac has to be greater than 0. So this one is just a little tricky. So our a value is 1. B, this whole thing is our c value. So we have b squared, so negative 3 squared minus 4 times 1 times k squared minus 4 has to be greater than 0. So negative 3 squared, so we have 9 minus 4 k squared minus 4 is greater than 0. So if we keep solving this, let's see, 9 minus 4k squared plus 16 is greater than 0. So 25 minus 4k squared is greater than 0. So if we subtract 25, negative 4k squared is greater than negative 25. Divide by negative 4. So we have k squared, our sign changes directions. And then we have to remember, these are the tricky ones. When we take our square root, we have to say positive k is less than the square root of 25 over 4, but also negative k is less than the square root of 25 over 4. So this one we just square root the top and bottom, so k is less than 5 over 2. When we divide by a negative, the sign changes, so k is greater than negative 5 over 2. So when we look at these, it's greater than negative 5 over 2, but less than, kind of think number line. We have 5 over 2, negative 5 over 2. So it's greater but less than, so we can write it as a single inequality. Negative 5 over 2 is less than k is less than 5 over 2. So the second one, let 3 times x plus 1 squared minus 12. Show that it equals, and then we have it in standard form. So from vertex form to standard. So we have 3x plus 1 times x plus 1 minus 12. So if we distribute, we have 3x plus 3 times x plus 1 minus 12. So we keep distributing here. Let's see. We have 3x squared plus 3x plus 3x plus 3 minus 12. And so that equals 3x squared plus 6x minus 9. For the graph, write down the coordinates of the vertex. So your vertex, well, we have it in vertex form right up here. So our vertex would be negative 1, negative 12. Write down the equation of the axis of symmetry. Well, that goes through our vertex. So through negative 1. Write down the y-intercept. Well, I'm going to use the second equation. So we have 3 times 0 squared plus 6 times 0 minus 9. So it's 0, negative 9. Then this last one, find both x-intercepts. So we have to factor to find the x-intercepts, or quadratic formula. So let's see, what multiplies to negative 27 and adds to 6? Well, that could be 9. Wait, so let's see, what is it? Negative 27 and adds to 6. That's 3x squared plus 9x minus 3x minus 9. So to this first one, we can factor a 3x. So we'd have x plus 3. So we want it to be x plus 3, so let's factor out a negative 3x, x plus 3. So it factors into 3x minus 3, x plus 3. So where are our zeros? Where does 3x minus 3 equals 0? Well, that's at x equals 1. And this one's easy. That'd be at x equals negative 3. So if we graph it, 1, 2, negative 3, positive 1. I mean, that makes sense now that our axis of symmetry is right in the middle. Negative 1, negative 12. So that's going to be way down here. That's not going to fit. So I'll just put it right down here. Then you got 0, negative 9, 1, 2, 3, 4, 5, 6, 7, maybe here. And we have the parabola. So the next one here. Oh, it's still related. We got 2D. Let g of x equals x squared. The graph may be obtained from the graph by two transformations. A stretch of a scale factor t in the y value followed by a horizontal and vertical transformation. What are the horizontal and vertical transformations in the scale factor? So basically it's saying we have x squared, and it goes to what we had up here, 3x plus 1 squared minus 12. Well, so it moved to the left 1, down 12, and our vertical stretch factor of a scale factor of 3. So this one's bad. It's just kind of realizing what problem it's talking about. So number 3, the following diagram shows parts of the graph of a quadratic. So our x-intercepts are negative 4, 0, and 6, 0. And then it has our y-intercept of 0, 2, 40. Notice that's the y-intercept, not the vertex. Write down f of x in the form f of x equals negative 10, x minus p, x minus q. Well, this is intercept form. So we know it has to be negative 10. Well, if it's minus 4, it's got to be x plus 4 and x minus 6. Find another expression for the form in vertex form. Well, vertex form, okay, so that's our y-intercepts, but our vertex has to be right in the middle. So what is negative 4 plus 6 divided by 2 is 1. So this coordinate right here is 1 and then something. So if we plug in 1, 1 plus 4, 1 minus 6, negative 10 times 5 times negative 5. Well, that's 250. So we have f of x equals negative 10 x minus 1 squared plus 250. So 3c, show that f of x can also be written in this form. So that means we have to multiply it out. So we have negative 10x minus 40 times x minus 6. So if we distribute negative 10x squared plus 60x minus 40x, 40 times 60 plus 240. So we have negative 10x squared plus 20x plus 240. And then number 4, to finish this page. F of x equals the square root of x minus 5 for x is greater than or equal to 5. Find the inverse evaluated at 2. So inverse, we switch the x and y. So x equals the square root of y minus 5. So let's solve for y. So we square it. So x squared equals y minus 5. So x squared plus 5 equals y. And now if we plug in 2. So 2 squared plus 5. So that gives us 9. Let g of x be a function such that the inverse exists for all real numbers. Given that g of 30 equals 3, find f of g of negative 3. So let's see. F of g of negative 3. Well, we have our f function, so we need to put our inverse in there. Well, let's see. On g of x, we know that the coordinate is 33. So on our inverse, we know that it's 330. So our inverse at 3, so this is really f of 30, because we're evaluating our inverse at 3, and we know 3 out pops 30. So this would be the square root of 30 minus 5, the square root of 25, which is 5.